This is a continuation of a previous Higgs video. You want to watch the one before this one. Pseudo-Goldstone, Higgs Mass Boson, NONET, Higgs Electromagnetism, CERN Atlas. So this was filmed on September 24th. So Pseudo-Goldstone Boson, was researched September 24th, and I didn't get around to filming it till November 15th, 2012. So this is a pseudo-Goldstone boson. This is the diagram for it. Different NONET of particles. So I'll give you a minute to look at all that. Okay. So September 22nd is when I was doing the research. Quote from Wiki. Keywords found in data. Combinations of one U, D, or S quarks and one U, D, or S antiquark in JP equals 1 configuration also form a NONET. Okay. Spectroscopic state, quote from Wiki, spectroscopic notation provides various ways to specify atomic ionization states as well as atomic and molecular orbits. And so each word that I Googled, I find out what it means. Okay? NONET Google, in particle physics, a NONET is a set of particles transforming as a 9-dimensional representation of some symmetry group. One such occurs in mesons. So here's another diagram for you to look at. I got some birds outside the window here yapping. Okay, so mesons of spin 0 form a NONET. There's all that. Let's go this one. There's CERN. Look how big these things are. They're huge. These are people. They're so tiny. These things are massive. This is what they use to find the Higgs boson particle. Isn't that crazy? Scientists at CERN use the enormous ALEPH detector in their search for the Higgs particle. Electromagnetism describes how particles interact with... Just a thought about this. Remember when we started making computers back in the 80s, how huge they were? I'm going to foretell that in the next 10 or 20 years, our detectors are going to be very small, just like our computers. That's just the feeling I've got anyways. So, quote, electromagnetism describes how particles interact with photons, tiny packets of electromagnetic radiation. In a similar way, the weak force describes how two other entities, the W and Z particles, interact with electrons, quarks, neutrinos, and others. There's one very important difference between these two interactions. Photons have no mass, while the masses of W and Z are huge. In fact, they are some of the most massive particles known. So that's on www.exploratorium.edu. Okay, so September 22nd, my thoughts. This is when I did the research. The key word is electromagnetism. If the masses of W and Z particles are huge, then we need to interact them with the Higgs particle formulas to create some staying power for the particle so that it can be studied within minutes instead of seconds. The formula idea based on the data here. So, electromagnetism, particles, photons, Higgs signal, radiation beam, weak force, W, Z, boson, particles interact, electrons, quarks, neutrinos, other particles, photons equals no mass, W, Z, huge mass, Higgs particle, equals particle with Higgs boson mass to study for more than a few seconds. My thoughts. How do you mix Z plus W with a Higgs particle by using neutrinos? Add your supersymmetry, your fermions, your split leptons, liquid argon gas. So the WOW formulas have all the keywords. I will have to do a cross-reference to see what they say to do. Thank you for watching this video. I'm going to go on to the next one.